So, hey guys, my name is Jithin, and I'm Shahul, and we are going to be talking about evaluating RAG pipelines with an open source framework that we created called Ragas. So, first of all, starting, what is retrieval augmented generation, right? It's basically when you build with LLMs, LLMs are very good to answer questions and solve problems on like data distribution that it has trained on and it knows. But soon as you go out of that distribution, it starts like to have a hard time. It starts hallucinating. It mixes up facts, and all that problem is there. So one way of like overcoming that is fine tuning. You can like fine tune the models on your data, but that's not very scalable. You don't know exactly what all things are changed, and it's hard to keep it updated when your data is changing. So one of the most like scalable things that has happened is like RAG pipelines, where the whole idea is when you have a like a query that the user gives to an LLM. Okay, when you have a query that the user gives to an LLM, you try and retrieve the data that is the most relevant to answering the question, and you give it into the LLM. And the LLM can then use that to figure it out. So how we do it is we add an extra component called a retriever, whose job it is to index all your data sources and figure out, if you're given a question, given a situation, what the most relevant pieces of information is. So this is a super hot field right now. We have members from Llama Index and like all, there are a lot of companies here working on that as well. But we were excited about this like a few months back. We built a few pipelines. We had a few consultation gigs, and quickly we reached a roadblock because we will build something very fast, and we'll be at a point where it's good, but we don't actually know how good it is. We don't have strong evaluation metrics to figure out how good these generations are, right? So like that is not a good way, because we don't know how to actually, like if we make a small change, we don't know how much of a change what that was, how much like better the system got, or if it got worse. And that is a big problem when you take these like pipelines into production. So because like in order to make any improvements on any of our systems, we first have to have like a solid measurement for that. And without that, we are just shooting in the dark, and that was exactly our case as well. And like at the end of the day, like having a like objective pipeline is very important, because at like what we care about is what our users are saying, and having a very good evaluation pipeline is like a proxy, because you don't want to be there. You deployed something, and then the user, like, instead of the user coming and telling that sucked, it's better to have your evaluation pipeline say that it was bad. And in the words of like ChatGPT, measurement initiates the dance of progress, where control takes the lead, gracefully guiding us towards improvement. So that is why measurement is very important for making improvements. And now Shahul will tell some of the ways, things we tried out and what worked.
Yeah. So, passionate about solving this problem, we looked into literature, and we took some of the popular metrics available, and we adopted some of the popular metrics from literature, and then we implemented it as our first version of Ragas. So that's Ragas version 1. But trying it ourselves and talking to users, we found that there is a difference between what's there in literature and what's expected from the industry, right? So why is this different, right? So most of these literatures, they follow, they do have a gold standard test set to which they can measure the performance of your pipeline against. But people building retrieval augmented generation pipelines, they do not have it, because building such high quality data set is expensive, and maintaining such a data set is very, very hard because of issues like data drift. And on top of that, many of these matrices like XAD match, blue scores, etc., are very, very, very much outdated for the current capabilities of LLMs, right? So then how will we do it? So we identified that there is this issue with the first version. We went back to the drawing board, thought about the fundamental issues of fundamental dimensions that people care about when they build such a retrieval augmented generation pipeline. So we figured out that from our experience and from talking to users, that retrieval augmented generation pipelines are actually meant for applications where there should be there is very high importance for dimensions like factuality. So the content you give out should be very much factually consistent with the context you are giving the model. So that's very, very important. For example, Prasenjit was saying about this. Their use case where they are grounding the predictions on the course curriculum. So you can't expect the model to predict anything that is outside the curriculum, right? So model might not know a lot of information about the question asked, but the model is not expected to give answer outside the curriculum. So that's the importance of text groundness. So that's one dimension that we identified, and other dimensions like relevance also matters. So we did some research, and then we formulated paradigms using proprietary and open source LLMs to measure, to evaluate such system using LLMs itself with high accuracy. That's something that we found out that is the way to go in the future. So then Ragas version 2 we just released it yesterday. It's completely open source, and fortunately it's gaining traction. So we are very excited to hear from you. If any one of you is building retrieval augmented generation pipelines, yeah, sure, yeah.
Yeah, so we have a solution. We are into legal AI, and we have this along with Diberta and T5. We are using that's in production since an year, and it's working pretty well. Now we are we are training the T5 on RAG front, and I'm interested in knowing that in retrieval model, I guess we are using FICE vector database, and then a DPR mechanism to fetch, and then this DPR gets fed into the model, right? So this is our architecture, what we have.
Yeah, everyone has, people are trying to build these stuff in-house. But we are actually focusing on building a high quality stuff that anyone can use, anyone can use at any stage. And also the thing about evaluation metrics is that these evaluation metrics should have very, very high correlation with human judgment, right? So building something in-house, you'll have to have a test set where you measure, the performance of the metrics itself against human correlation, and you'll have to make sure that this is also scalable. Or if you are using something like OpenAI models to do it, firstly, what is the correlation with human judgment, and other thing is that is it scalable in terms of the expense, right? So most people would like to run evaluation on more than 100 samples and everything. And if you run evaluation on something like more than 100 samples, and it will, depending upon the token cost, it is going to be expensive. So once we have enough number of users, we are in the process of fine-tuning models that is expert in fine-tuning steps. So this could bring the cost down to maybe like 1/100th of the cost that you are paying to OpenAI, and thus evaluating the models just using an API, right? So I hope that must be convenient. And this is how you can use our library. It's very, very simple. So you just need to import the library and use your OpenAI key. The custom model will get loaded automatically. And then you just need question, context, and answer. The important thing here is that you don't need any ground truth to evaluate your pipelines. So the first version, we wanted users to make ground truth, but we understood that that's not happening because it's very expensive process. So that's the thing. And thank you we will be here. Come talk to us, and we'll be also present at the after party, and also check out the repo, the QR code. And anything about LLMs, come talk to us.